Hello friends, welcome to my channel Academic Made Easy PC.
If you have not subscribed my channel, subscribe it and also press the bell icon.
Topic is Venn diagrams. Venn diagram is one of the important diagram, okay? So it gives the relation between the set. For example, so this is the Venn diagram, okay? It is nothing but it consists of a rectangle and circle, okay? If one set is given, we will be taking one circle, or it depends on the number of sets given, okay? But always rectangle denotes the universal set and the circle denotes the given set, okay? So for example, let me take a universal set as 1, 2, 3, 4, and 5. Okay, the set A, B, 2, comma 4. Okay, so now how will I represent it in the form of Venn diagram? Let me show you. So, the universal set means even including the circle it is there. Okay, so I will write 1. In set A, I have 2. No, so I will write 2 over here because this belongs to A as well as universal. So I'm writing it inside the circle. 3. Next is 4. 4 is represented in A also. So 4 and 5. You can write anywhere, but this condition should be satisfied. Why? Because A is present in U also. A is a subset of U. No. So only I'm writing 2 and 4 inside circle. Okay, so this I'm representing it as A and U. So the circle is the given set. My given set is 2 comma 4. That one I'm writing it over here. Okay, this is what Venn diagram is all about. One more example. U is equal to 1, 2, 3, 4, 5, 6. Okay, so let me have A is equal to 1, 2, 3. Next, B is equal to 3 and 5 alone. Okay. Now I have one universal set. Since two sets is given here, I have to taken two circles. Okay. As I said, it depends on the given number of sets. No, my given number of sets is 2. So I have taken two circles. Okay, so in the universal set, every elements is present. What are those elements? 1, 2, 3, 4, 5 and 6. No, so in set A I have only 1, 2, 3, and in set B I have 3 and 5. So now let me start writing it in the Venn diagram. So 1 is present in the universal set as well as A and not in B. So I will write inside A, the circle A. Okay, so now next 2. 2 is present in U as well as A, not in B. So I will write it inside circle A itself. 2. Okay. So next 3. 3 here. Here. In all the 3 sets I have 3. So where should I write now? So this part, inside this part. Why? Because this is in universal set as well as the elements in set A and B will be written inside this part. Okay, why means this is the intersection. When we are joining these two, this part is common for both. So since this element is common for all the three sets, I am writing it over here. Okay, so next 4. 4 is only in universal set, so I will write anywhere inside the rectangle but not inside the circle. Okay, so 5 is over here and not here, and over here in B, so I will write 5 here. Then 6 is present only in universal set, so I will write 6 here. Okay, so this part is only for A till here. Okay, till here set A alone. Set A alone. Okay, so this part will have set B alone, and this part will have set B and set A's common element, and the whole thing will have universal set. Okay, The relation between set can be represented by means of diagrams which are known as Venn diagram. Okay, as I explained you, the same thing only is written over here. It consists of rectangles and closed curves, usually circle. I said universal set will be represented as rectangles and the given set as circle, that is closed curve, that is nothing but mostly we will be using circles. Next topic is operations on set. In this topic, we will be learning what all operations, that is concepts that can be applied on a given set or sets. Okay, so there are two types. One is union of sets and the other one is intersection of sets. Union here means, as the name suggests, union means all together. Okay, so two sets will be given or three sets will be given. We have to write a particular set in a combined way. So now let us see how to write it. First, I'll give you an example. See, I have taken the set A is equal to 1, 2 and 3 and the set B as 2, 3, 4 and 5. Okay, so now I have to find the union of sets. Union of sets means this set A plus set B. Okay, so now I have to find union means I have to just add. Okay, so if I adding means not the elements, you're joining these two together. Okay, so I have 1, 2, 3 and 2, 3, 4, 5. No, so in union of sets, we will be writing all the elements that is present in both the sets except the common sets. For example, when I take here 1 is here and not here, so just directly I will write 1. Okay, so next I have 2 here as well as here, so I will be taking any 1 2 only. I won't be taking two twos also. Okay, 3 also twice I will take any 1 3, so I will have 3 one time only. Okay, so now I have 4 here, I don't have here. 5 also here I don't have there, so I will write 4 and 5. Okay, so in union of sets, you're just joining those two sets, but we will not be writing the common elements twice. Only once we will be taking. Okay, so that is union of sets. Now let me show you the definition. The union of two sets A and B consists of all the elements of A and all the elements of B. The common elements being taken only once. This had to be noted. Only once we will be taking. Okay, we use the symbol U. It is not U actually. This is union. It is just like a U but a broader view. U. Okay, broader U we will be using to denote the union. Okay, and so I think you will be clear with the definition as well as the example. So we will be taking all the elements and the common elements will be taken only once. Okay, so now let me teach you all to draw the Venn diagram. So already I have taught you what is a Venn diagram. This U represents the universal set, that is a rectangle represents the universal set and the circles represents the given set. Since I have two sets over here, I have taken two circles. Okay, so first I will have A and then B. Okay, this is my set A. This circle represents my set B. Okay, so now I will start writing the elements. So first in set A, I have 1 and not here. So I will write 1 over here. Okay, so 2 is here. In both the sets I have 2 and also 3. So I will write in the intersection. In the previous topic I said you why did I write, because it is an intersection. No, intersection means both also having common elements, so I will be writing it over here. 2 and 3, so that I will not be in the position to repeat the given elements. 4 and 5 is here. 4 5. Okay, since I don't have a universal set given, I'm just leaving it just like that. Okay, I just taught you to draw Venn diagram. I didn't just go deep into it. Now we will just see how to represent it. Okay, Now I'll say you how to represent A union B using a Venn diagram. Okay, so now I have got A union B. No, so 1, 2, 3, 4, 5. Where and all 1, 2, 3, 4, 5 is there? I have to shade. Okay. Okay, A union B is nothing but A plus B. So I will be coloring this circle as well as this circle. Then by joining, I will have these two circles shaded. Okay. Next is intersection of sets. Intersection here also, as the name suggests, there will be 2 or 3 sets given. You have to find the intersection. It means that is a meeting point of those 2 sets or 3 sets. Okay, it depends on the sets that are given. First, let me see the example. The same example I have taken. Okay, so 1, 2, 3 in set A and 2, 3, 4, 5 in set B. Now I have to find A intersection B. So this symbol represents intersection. Okay, so now I have to check which elements are common for both the given sets. Okay, that gives me the intersection. Okay, so here I have 2 and 3 over here and 2, 3. So these two elements are alone common. So I will have 2, 3. This is my required set for A intersection B. Okay. So now how to do it in the Venn diagram, let me show you. So as we did for the previous example, I will be doing for A and B and this will be U. Since my universal set is not given, I'll just leave it just like that and I will have 1 here, 2, 3. Okay, so 4 and 5. I have already taught you why I am writing like this. Okay, so now let me show you how to do it in the Venn diagram. So see here, we have taken only the common element. Okay, we have not taken all the elements, we have taken only the common elements. So in the Venn diagram, what had to be shaded? That is the common part. Okay, we have to check what is the common part for both the given sets, that is A and B. See, yeah, only 2 and 3 is common. No, so I will be shading only this part. So this part will be shaded. I will not be shading this and this. Intersection means only this part should be shaded. Okay. Now definition. The intersection of set A and set B is the set of all elements which are common to both A and B. We use a symbol. I said no, this symbol is used to denote the intersection. Okay. So here we will be learning some special properties for union and intersection. Okay, there are some properties that can be applied for union and intersection. So now let's see it one by one. First one is commutative law. Commutative law we are learning right from the lower classes, so we will be very familiar. Only difference is over here union and intersection will be there. This is applied for both also. A union B is equal to B union A, and also for intersection A intersection B is equal to B intersection A. Okay, so now even associative law is very familiar. So the associative means it is just like group. So the elements which are near equal to signs will be grouped. So A union B union C is equal to A union B union C. Okay, so next for intersection is A intersection B intersection C is equal to A intersection B intersection C. Okay, these are the two properties and we'll move on to the next property, that is law of identity element. Identity element over here is phi and u. Okay, so phi means it is a null set. U means here it is universal set. These two sets are called the identity element. Okay. So here for union, A union phi is equal to A. For example, when we take here A is equal to 1 comma 2 and B is equal to 5. Okay. So when I take for A union B, we have to take all the elements from A as well as B, but the common elements should not be repeated, isn't it? So here, since my B is 5, that is null, no elements are present in set B. So therefore, I will write only 1 comma 2, which gives back the answer as A. So only I have written A union phi is equal to A itself. Okay, so now I'm moving on to intersection. A intersection phi is equal to phi itself. Why? Because my A is equal to 1 comma 2 and B is equal to 5. No. So when I take the intersection means we have to take the common element for set A and the phi. We don't have any common element, so I will have that also as empty. Okay, so now A intersection U is equal to A. It means like for example A is equal to 1 comma 2. Okay, so U is equal to 1, 2, 3, 4 and 5. Okay, so now we have to take the intersection for both also. So intersection means we have to take the common elements only. What are the common elements? 1 and 2 should be there. So 1 and 2 is over here also. Okay, so I have 1 and 2 only, so I have A as the answer. Okay, so now idempotence law. Idempotence law means a set with itself. So for union means A union A is equal to A. For example, if I have A is equal to 1 comma 2 and A union A, if I want, what will I do? I will take all the elements of A union A except the elements that are common. We will be taking only once. Okay, so if we take only once, everything will be taken once only. So I have only 1 comma 2, so I will get back the same A itself. Okay, so now A intersection A is equal to A only because A is equal to 1 comma 2. No, so if I take intersection, what is that intersection? We have to take only the common elements. Every elements in A intersection A is common, so I will have the A set itself. Okay, so now law of U is nothing but universal set. Don't get confused for universal set and union. Okay, so in textbook it will be given a broader U. Okay, so that you will be able to differentiate between universal set and union. Okay, so union of universal set and set A is equal to universal set itself. For example, when we take U is equal to 1 comma 2 comma 3 comma 4 comma 5 and A is equal to 1 comma 2, if we take the union, what will we get? We will be taking all the elements of U as well as A except the common elements will be taking only one. So 1, 2, 3, 4, 5 itself. So we got back the same set, that is U, no? So therefore I have written U. Okay, so now distributive law. Okay, distributive law is very similar to this law. Okay, as we learnt in the lower classes, no, A plus B into C is equal to A plus B into A plus C. No, the same thing over here. A intersection B union C is equal to A intersection B union A intersection C. Okay, it's just like multiplying this inside. A intersection B union A intersection C. Okay. In this topic, we will be learning difference of sets. Difference of sets, no. Here it is just same as difference of a number. Difference of a number means we will be subtracting, isn't it? Even in the difference of sets, we will be subtracting the two given sets. Okay, so first example, A is equal to 1, 2, 3, 4, 5, 6 and B I have taken it as 2, 4, 6, 8. Okay. So now I have to find A difference B. Okay. So now how will I find A difference B means I will be taking all the elements from A. Okay, I will be taking all the elements only from the set A, but I won't take the elements which are in set B. Okay, A difference B means I will be subtracting the elements that is in set B. Okay, so here I have 2, 4, 6, 8. Okay, so I will be subtracting 2, 4, 6, 8 from set A. So set A2 will go 4, 6. So what are the remaining elements now? 1, 3 and 5. Isn't it? So I will have 1, 3, 5. That is my required set for A difference B. You can also say it as A minus B. A minus B and A difference B is same. Okay, so now when I have B difference A, it means that I will have all the elements from B except the elements that are common in both A and B. So I will have 2, 4, 6 as common over here. No, so only I will be left with 8. So my required set is this. Okay, so now I think you will understand when I show you the definition. The difference of the sets A and B in this order is the set of elements with belong to A but not B. That's what I said. No, we will be taking only the elements from set A and no, we'll reject the elements which are common in both the sets. Okay, so only I have taken only 1, 3, 5 and here I have taken only 8. Why? Because the common elements should be rejected. Okay, so now one more important thing is that the sets A difference B, A intersection B and A B difference A are mutually disjoint. It means that they don't have intersection. The intersection is equal to 5. Okay, that only they have given here. And one more important topic is disjoint sets. Okay, now let me give you an example for disjoint set. For example, A is equal to 1, 3, 5 and 7. Okay, so set B contains 2, 4, 6, 8. Now, if we have to find A intersection B, what is the condition? We have to take the common element, isn't it? Is there any common element for A and B? No, therefore it is 5. So therefore we will say that A intersection B, it's a disjoint set. That is A and B are disjoint. It means it is not joining in any point. That is the thing. Okay, that is what disjoint set means.
If you have any doubts, mention it in the comment box.
Next topic is complement of a set. Okay, so in this complement of a set we will be learning a new method. Okay, so now let me give you all an example. So here I have taken U and A. Okay, in complement of a set, only universal set and one more set will be given. Okay, so in universal set, the common elements, that is the main elements, will be present, and in the given elements you have to check. Okay, so what is complement of a set means? We will be having universal set and the given set, isn't it? So now complement of a set is nothing but U difference A. That is a complement of A. It means that we will be taking U difference A by rejecting all the elements which are common to U and A. Okay, so now let's get started. So 2, 4, 6, 8 is present over here in A. So we have to leave all those elements in universal set. That is 2, 4, 6 and 8 will be rejected from the universal set, and we will be writing 1, 3, 5, 7, 9 and 10. This is the required set. A complement. This is represented as A complement. Okay. A dash means it is A complement. A dash means except the elements that are present in A, we will be writing all the elements from set U. That is universal set. Okay. Definition: let U be universal set, A be subset of universal set, then complement of set A is the set of all elements of U which are not the elements of A. I said no, we should not take any elements from set A. Okay, so the formula is A dash is equal to U minus A, or U difference A. We won't be having even an element from the set A if it is A complement. Okay.
If you have not subscribed my channel, subscribe it and also press the bell icon.
Properties of a complement set. Okay, so as I taught you the complementation of a set, so here we have some properties also. So for union, intersection and all those. Okay, first is complement law. You have to keep all this law in mind so that it will be very easy for you all to answer one words and etc. Okay, so A union A dash is equal to U. It means like you have A is equal to 1, 2. Okay, so U is equal to 1, 2, 3. Okay, so now A dash will be 3 alone. Okay, I think you will be clear from the previous topic. So if I add these, it means union, no? A union B will be 1, 2, 3, which is U again. Yes, no. So only I have written this. Okay, if we take intersection, intersection means common element. So here no, nothing is common. So I will have 5. A intersection A dash is equal to 5. Okay. Now law of double complementation. Double complementation means what? A dash the whole dash is equal to A. It means I said no already over here. I said that U is equal to 1, 2, 3. A is equal to 1, 2. A dash is equal to 3. Okay, so A dash the whole dash. It means I have to leave this 3 except 3. I have to write all the sets from union. So I will have 1 and 2 where I got my A itself. Okay, that only I have written A dash the whole dash is equal to A itself. Now, law of empty set and universal set. Empty set, that is 5 dash is equal to U. 5 means what? Nothing. Okay, so nothing dash means nothing is there, so I have to change it means what? Everything should be there, no? Just like that. So I will have universal set. Okay, now I will have universal set. Universal set will have all the elements. If I take complement of that, what will happen? If all elements are there, nothing should be there. That's the opposite, no? So only 5. Okay, next comes the two very important formulas where we'll be learning almost in all branches, like even in computer we will be learning. So probability, relations and functions, sets, everywhere, wherever you go, we'll be able to see this De Morgan's law. So it is better to learn thoroughly. So this is one of the very easiest formula also. A union B the whole dash is equal to A dash intersection B dash. So now we will be seeing the proof later. Okay, so since this proof is there in exercise also, I will teach in the exercise. Okay, so now we'll just see the formula alone. So A union B the whole dash is equal to A dash intersection B dash. So see, first we will be having the complement for the whole set. Then for separate, that is separate sets, okay, that is A dash B dash. So here if we have union, here we will have intersection. Okay, so next you see A intersection B the whole dash means separately we had, then here it was intersection, here it will be union. Okay, practical problems on union and intersection of two sets. This also is one of the important formulas. we will be learning. Okay, so not only in class 11, even in class 12 we will be learning, and also in higher studies. Okay, so if A and B are finite sets and A intersection B is equal to 5, that is nothing is common for both, then we will be using this formula. If not, we will be using this formula. Okay, when only two sets are given. Okay, n of A union B. I taught you what is n of A union B. No, number of elements in the set A union B is equal to n of A, that is number of elements in set A plus number of elements in set B. Okay, so next one is when A intersection B is not equal to 5, any element is present, then it means n of A union B is equal to number of elements in set A plus number of elements in set B minus number of elements in set A intersection B. Okay, so next we will be seeing for three sets. Okay, so n of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection, this intersection B, okay, minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. This also is very important, and this also is very easy. See, to find the number of elements in A union B union C, no, just add all these elements. Okay, that is n of A, number of elements in set A, B and C. Then you subtract with number of elements, take two sets, okay, two pairs, like, then you will have A intersection B, then B intersection C, then A intersection C. Okay, just come like that. Then after that, add number of elements in all the three, that is A intersection B intersection C. That's it. This will be very easy, and the introduction part for the first chapter is over. And now let's see for the exercise in the next video.
If you have any doubts, mention it in the comment box.
Like, comment, share and subscribe.